Hello everyone and welcome to today's live stream where I'll be taking this project that I made, I think maybe 3 months ago, maybe a little bit more. Been working on it for a while and I finally got a good version 3 months ago. And now I want to upgrade it to use Blender's new matrix nodes in Blender 4.2. So for those of you who don't know, Blender has gotten some new matrix nodes like combine transform, and all of these right here. So invert matrix, multiply matrices, project point, separate transform, transform direction, transform point, and transpose matrix. Now I'm going to be using these to basically condense a lot of what you see here. Basically this setup hold spaces using basically transform data but separated into position, location, and scale, which is what a transform is in this scenario. So that's the plan. The plan is to basically take all of this and just optimize it, which this will take a while, so I hope you're prepared for that, but it'll be good to see how it works. So in theory, when I replace this first node, this first transform position node, it will be exactly the same as before. So let's do our first replacement. As we can see, absolutely nothing has changed, which oddly enough will be what we want to do for a majority of this project. Just basically replacing parts one at a time, ship-of-thesising it, and it should be perfect. Will it? Probably not, but we will see. And also, I do want to take note of the timings. This is taking around 3 milliseconds, around that. So that should be good. Oh, and here are other objects that I have put this effect on. This is an advanced effect, but with the matrix nodes, it should be better and easier to do. But I really want to make sure that I can transfer it properly. Fortunately, these nodes are completely unnecessary, I think. And then, let's see, that... I wonder why that's there. Is that even needed at the moment? Which cost? Oh, it's semi-needed, but not really. This has gone through a few changes since that little demo or breakdown that I put on my YouTube channel. Basically, it gets the shortest path data to find the face parents, and then it gets the parent face corners, which we can see happens here. This took a lot of figuring out in order to make it work. But now it should be good, I hope. So the point of this is to, again, make it so that it all just works. So this will be face transform, so let's just abbreviate to ftrans, which should be good. Combine transform, let's have this be the rotation, location, and scale. So that part is now converted, but I will keep the old parts, just so that it will work. Just so that I can compare what will work normally. We'll see. Okay. Are there any problems with the stream? Because I'm currently getting a bitrate issue. But it should be okay. Should be. It still seems to be replaying at the right frame rate. So, a lot of this will just be taking data like this and then like finding the local location, rotation, and scale. So that makes me think, how would I do this properly? I guess, need to find out how to undo a transform, which should be simple enough, but we will see. So let's take this, that's the face local position, so let's do a transform point, and then what we need to do is use a combine, transform. This is going to be an interesting ship of Theseus. Again, let's invert this matrix. Oh, invert matrix. So when I replace this, it should be perfect. Okay, nothing changed. That's good. That part is now replaced. Okay, we're getting there. Actually, I'm anticipating a curveball in the second half. But for now, it should be okay. So we want to do the same thing right here. Then here's the face local position. which in this case, I'm transforming the faces, and then I apply that to the vertices. So, yeah, something like this should, again, when we replace this, there should be absolutely no change whatsoever. As we can see, that works out as well. As we can see, this is getting... the setup is getting smaller, and it will get even smaller to the point where we don't even need face position and rotation. We just have one transform, which means that we'll do one kind of lookup call, I guess. Well, for lack of a better term, one evaluation. And then... face local rotation. Wait, did I? No, I did not replace all of these yet. Okay. I'm working backwards, which in hindsight is probably a really, really bad idea. But we'll figure it out. I need the transforms relative to parent, which means I'll probably need to use a multiply matrix node, because I did a little bit of research since the previous stream, which it now no longer exists, because I was trying to figure out some of the matrix math. Okay, so seeing that part's good. I'll collapse the invert matrix thing because that just makes it a bit better. Okay, how are we doing on the timing? It's around the same, but I do see a dipping. I have converted this into a matrix version in the past, but that was with an old version of the nodes where now it won't even open, which is very unfortunate. So I'm redoing it. But I think this time it will be much better because we have a better base. So now I guess it's how do we get the face local transform? So right now that's a global transform, and now we need to make a local transform. So how would we do that? So we have, actually, this is a good base, but we need to make a new value. Come on, work with me here. Instead of this, we'll have a face local transformation. So go, let's put this right over here, make it a 4x4 matrix. Then with that, like that, let's go and get a named attribute, which actually, let's go and make this a quick favorite. There we go. So we can easily call it because we'll need that a lot. So we have the face transformation, and then we will multiply this matrix. The top one's like the parent, if I remember correctly. Get that, and then we evaluate. Actually, let's just go and yoink. So from there over to there. This is the Blender 4.2 Alpha. I got it, I think, yesterday night. But whichever one you download from blender.org, it'll be fine. This is not a build of Blender. I do have a custom build of Blender where I update that and do all the command prompt stuff. But this is just the one that you can download from Blender's website yourself. So now that I do this, if everything works, which I really don't think it will. Let's see. That. Got that. Let's get... Hello? Okay. Base local transformation. Then I want to separate the transform. And that affects that. So in theory... Actually, wait. Where does the local transform do stuff? Base local rotation, that, and then here. Just the plain old rotation. Oh, that would be there. Okay. Let's just go and yoink this out of here. See what that looks like. This probably won't work. Yep. Afraid of that. Let's see how we... Okay, what was I doing? It's right here. So let's see what needs to be done. If I flip these around, it's still broken. So I need to invert one of these. Since I do not know the proper math behind this, I will just... Oh, look, it works! That's... Hey, if it works, it works. so now if I swap out the two of these, there should be no difference. There we go. I felt like that would work, even though, you know, it's always a 50-50 shot. So let's just do something like this to compact this. Now we can see that all of this, in theory, I still need to verify quite a few things. All of this was compressed into this, which is very, very nice. I have no idea about what's going on. Basically, we got some new nodes that will compress a location, rotation, and scale into one value, which in this case is a 4x4 matrix, and I am optimizing a node sub that I had before to use the transform data type, which in this case is shown in this very nice magenta color. I love it. But it's an optimization, just to make things hopefully faster, which in this case, it's, I don't know, too small to tell. Oh no, it is slower. In this case, almost twice as slow. I'm hoping that it will speed up when it's fully converted. So all of these can be just wiped out of existence. And then all of these can be wiped out of existence, but then I need to make sure that the base transforms get stacked properly. Which will be interesting. Will be very, very interesting. I need to make sure that the scale doesn't freak out. Base position, base local position, all that, and then that gets done by that. So this can be replaced. So if I use... This is going to be interesting. Like, in theory, all this can just be compressed into, like, I think probably 3 nodes, most likely. At least 3 main ones. But I'm going to replace parts of it so that I can understand it a bit better. And then we can do better stuff with this. So here we get the face... Wait, but that won't work. Okay, this all won't work until I actually ship a Theseus it. I'm going to save it because it's in a good position. Then we'll need to put in a new part right here. On ship a Theseus, don't fail me now. So here, again, 4x4 matrix. This will be base transformation, which is good. I'll keep that separate for now. But now... Dang, this is... I'm trying to figure out how I can replace it without it absolutely freaking out 100%. Because I could just use a combine node right here, and then boom, it's done, it's good. Actually, I can do, but it won't work properly. So let's use a transform point right here. Even though it might confuse me a little bit more, but we'll try it. That, and that's not undone, that is done. Here, I'm just getting rid of the node groups, and if we look at this, again, nothing's changed, we're good. Is as it should be. So what I'm hoping is when all this is done, I can replace this section with one evaluate, getting one thing, which should, again, should be good. Do this, that is, scale can be at 1, because we do not need to worry about it. Rotation's depreciated, but we don't need to worry about that at all. So now that we have face transformation, that means that over here, we can get a glimpse at the future. So, face transformation, if we just plug this into there we go. We've now eliminated 3 nodes. So that part is good. It works. So see that makes things a lot more simple. Again, reducing the amount of nodes from, like, I think there were, how many were there? Well, 1 custom node, and then, you know, just reducing it to like 3. So that's better. Transformation, that's doing that, which work as intended. Again, let's go back over to here because this is the most complex object so far. So we have that. Now, how do we make it so that the transforms work as they should? Because I could get the base local transformation, plug that into there, which actually that might. Okay, that seems to have worked. And then, here's all of that. Let me put that back there. Because, again, a gut feeling is telling me that we need to take the face local transformations, use a multiply matrix, and then let's go and yoink you once more, which one thing that I'm really annoyed with Blender is that you have to select the frame in order to Control C and Control V. My brain is going faster than my words. Sorry about that. I think I may have figured it out. Do that. We take that and then do that. This is the parent. This is the local. For lack of a better term. And then if we do that. No. Okay. That's not good. And that and then that. But I might need to... No, I don't need to invert it. Just get that, and then we rotate that by that. Which should be something along those lines. Because that's doing that, and that does that. Do this. That is quite interesting. Not what I want, but very interesting. Face parent and then face transformation. What we're doing is... transpose matrix? I don't know. I feel like I'm forgetting a little bit of the matrix map, but let's take a look. Multiply matrices, project point. There is, where is it? Transpose matrix, which feels like one of these may help. The transpose matrix basically flips, imagine if you took the matrix and then rotated it by 90 degrees to one side. It said, well, the Wikipedia article said it flips around the diagonal, which may explain some parts of it. Sure. In this case, I don't think it'll help, but if you just try a lot of things, maybe something will stick. Sting? Okay. What am I doing wrong specifically? So right there, well... So we're taking the local thing, and then we're transforming a position and location and scale. So we take one transform, which are these three. We're transforming it by another transform. So how do you transform a transform? Well, I assume you would use the multiply matrices node. And this is always wait a minute. So that is rotated by that. I've already tried both methods. My head should function. Unless part of it is not updating the way it should. Like, it feels like it should be working. Why isn't it? Let's take a look at the supporting data. The supporting data is good. None of this is dynamic. So it doesn't update itself again and again. Well, it's not a feedback loop. And we've already determined that face local transformation is working as intended. Or is it? Well, there's a way to find... There's a way to find out. Oh, no, there is. I just need to take you. Actually... The annoying thing is that I put some of the controls outside the node group, which is annoying. But in this case, it might actually help. So if I do this, we can see that that works perfectly. So we take a transform, and then we transform the transform by a transform. So here, that part is hereby replaced. And if I connect this over here... Oh? Oh no, wait, that's why. Oh? Wait. Oh no. It was working, but I forgot about one thing. Matrix is 0, it freaks out. Dang it. So no, it was working. The problem was I forgot to do this thing. I forgot to go and apply all the transform parts. Yeah. I understand now. So I need to separate the transform and then combine it. But the rotation, I manipulate outside the group. Yeah, that's a bummer. That's a bummer. So, once again, this was working as intended. It's just I forgot that I was manipulating it outside. So this'll work. We're going to be eliminating so many nodes, it will be incredible. It will be incredible. Just need to double check how I can manipulate it. Well. Is that, yeah, no, that'll work. I'm doing a lot of this process in my head, which I hope that's not I hope that doesn't affect the educational nature of the stream. I think you can probably see what I have cooking in my brain. So here, as we should see, that is working. But there's a problem, which is if the rotation and such is 0, it doesn't work. So now, we can eliminate basically a majority of this setup. So I think it's basically fully converted at the moment. Let me save this, because it does work. Now, let's do the fun part, which is eliminating all the unnecessary bits. So here, we can do dun dun dun, and we're just left with that. Here we go, just one node right there. That is so much simpler. I wonder if the timings are better in this case. So instead of all of this, we just have this. So, let's go and boom. Well, that means I'll need to make another breakdown of the setup. Which in this case, it'll be a lot faster to do. That's like that. Oh, I messed something up. Uh-oh. What did I mess up? Oh, the vertex local positions. Actually, no. Good. Ah, okay, right. I still need the vertex local positions. Just Control Z. Oh no. That's why we save! Alright, let me just go and refresh the save. Okay. Save refreshed. So now I need to make sure that the vertex local transforms, yeah, this one, does not get touched. I just need to make it so that this can replace that. Uh-oh. That makes me a bit worried. I'm worried about that. That should no. That's why I was worried. Actually, maybe this invert matrix thing, the option, if it's invertible, maybe that's the key. Because if it's not invertible, probably what's messing up with it. Wait, well, something's not right. Why would that freak out, but the other ones wouldn't? That works. Wait, why is it just shifting the issue? The end result's fine. You know what, maybe if we convert everything, it'll turn out well. So let's just go with that assumption. Kind of a naive approach, but let's try it. As we can see, like, It's so nice when a new thing comes out and it just fixes so much, makes everything so much easier to deal with. Again, right here, if we replace most of that, that part is still broken, which I will need to look into. So here, let's just go delete that, and... well, yeah, that could go. Again, eliminating so many nodes. This makes it so much simpler, and I love it. So here, this is good, okay. So now we should be able to, since it is pretty much completely converted at this point, just take this, put it in here, which means that so much of this, means that so much of this is just unnecessary and can be completely eliminated, making this much more efficient, in theory. It might end up being around the same speed. Actually, no, it should be faster. Because the there's only like one evaluate at index. Even though the matrix is a 4x4 structure, which means that there's 16 values in there, while the previous one I had was just 3 values for the location, 3 for the rotation, and 3 for the scale. Maybe 4 because there's a quaternion, so at the most 10, but this has 6 more floats with it. And also another thing, these nodes now have inline sockets, which is very interesting. It means that they're so much smaller, which is nice. Let's see. Okay, as we can see now, these are good, but I should probably label these a bit better. Yeah, well, so this is parent transform, and then this one is local transform. Go, you multiply those together and it just works. And the weird thing that tripped me up a little bit when I was first playing around with this is that these are not, you can't swap these around. Even though, if you're not familiar with matrix math, which I still am not, I thought, oh, multiply. If you multiply 2 matrices, then that means they're invertible, because you can invert a multiplication and it'll be the same. But with matrices, no. Because if I were to do that, let's just do an Alt-S, we can see that we get a vastly different result. Okay. Now that we, like, look how much smaller that is. It is incredible. Just go compress, compress, and compress. And it seems, the timing is basically the same. Maybe slightly slower. But in this case, I think the big optimization is just the node tree. Actually, could I highly doubt that the accumulate field node has a matrix. Yeah, no, it doesn't have a matrix. Thing right there, so I can't quite optimize that. The end result. But it's not perfect. It is still broken. Where for some reason the rotations are screwed up, and it does not make sense to me. It should be perfect. Like, why is it fine? Why would that be happening? I'm assuming that it looks like the issue is that when the parent and child both have a rotation of 0, it just does not work. Which I can probably prove this by just adding a little bit to the rotation. Just adding a little bit to make it inaccurate, to make it work. So if I do this, in theory... Oh. Yep, there we go. So that fixes it. But why would that do that? Just a little error. It just has to be something other than 0. Or close to 0. So why would that be? Someone mentioned in dev chat that the rotation sockets returns the wrong rotation value by default. I did see something about that. I wonder if it... Oh, no, it is that, isn't it? I've run... Okay. Yeah, that's a big error that has been plaguing a few projects that I and other people have been working on. I didn't think it would affect this one, but in this case... Yeah, okay. Let's actually let's do a little diagnosis. Wrong node. Let's do a store named attribute. Next is better now. Earlier today we took a look at EV-Next, and it is much noisier than regular EV and slower at this current time, which is very unfortunate. Maybe it'll be fixed, but it's been 5 years since EV came out, and the upgrade... I'm not a fan of how much noise there is in the next version, and blurry noise at that, but that's a topic for another time. Okay, let's do a little bit of debugging where I just do AAAR so that it'll show up first. Let's go and take a look at the spreadsheet. So let's take a look at the spreadsheet over here. AAR, where are you? Oh wait, we want this to be face domain, I think. Right, let's go over to face. And here we can see that this has a very small value, which, maybe we should store this as a vector because that'll be a bit more readable. Okay, so we can see that most of them have just a slight little low value, which I'm assuming these ones are the ones that freak out. So let's go and take a look at this. If I go and mute this node, not seeing a radical difference. Oh, no, wait. Yeah, let's see. Look at that. There is a big rotational difference, but I'm trying to figure out what's wrong with you. Seeing any of that. Wish I could highlight just the problematic ones. Like, that should not exist. Like, worst case scenario, I need to make sure that there's just some value in here, which will make it have an ever-growing precision error. But if we do that, that's fine. If we do that, that's where part of it breaks. If we do this, that part's fine. So we've isolated it to be only the y-axis, because I think that's what this one uses. And if it's 0, it rotates by 90. So yes, it is that issue, which is very, very annoying. And if we go any further, I think it'll act like it's 0. So that... Don't you love it when new bugs get introduced? Though... No, I can't do that. I was saying, oh, I can just store it as a vector, and then we should be good. But... in that case, let's just roll with the punches for now. In this case, the speed is pretty much the same, which I'm genuinely surprised by. Because I thought it would have been faster. But it seems to be about the same, maybe a tad slower. But I still think that's worth it. Maybe. There is a way... No, I want to keep the vertex local positions as a vector instead of a transform, because that would basically make our problem 4 times worse. So this is the best version of this so far, the most optimized, much better than the version I had previously. All this needs is a non-zero thing. Let me actually do a little bit of documentation right here. Actually, let's go and reorganize this a little bit. So this will be 0, rotation, bug fix. That's very weird. And, well, we'll just have to deal with it. There we go. That is the upgraded version of the face rolling, and it is significantly better and easier to understand. Like, you don't need to know what the individual nodes do, you just need to know that setting them up in this order is better. So this will do local, actually wait, face, local, transform. And here, let's relabel this to be position. Even though it's kind of like a transformation, it's kind of not. Well, no, it's not a transformation. So this will be face transform, which here, let me turn off the timing so that we can see this. Face transform. There we go. Here are face corners. Nope, that is as it should be. This is a bit more complicated because unfortunately there's no way of getting the correct total cost or the kind of iterations to center, so I need to do this workaround in order to make that happen. You could condense this into just one shortest edge paths node, but the edge cost would have to be 1, and then you feed the total cost into the loop ID. It's kind of unfortunate that that has to happen, but it does, so actually I could show that. So let's just do, I probably should have saved this before I tried this, but let's just use a float, just a value. And then if we just plug this into here, we should see... Excuse me, why are you messed up? Oh, yeah. Because I did on only one axis when apparently... Okay, we need to introduce more... The, hey, please, for the love of all that is holy, do not go to 0 because that is bugged. There we go. So yay, that works. There is a little bug, but that is not my problem. Well, it's my problem, but I can't solve it. Okay, good to know. I'll probably make a bug report. Well, there's probably already a bug report about that. It's probably been around since Blender 4.0. We'll see. Yeah, that is much better. And now I guess I probably don't even need node groups at this point. But I don't want to risk it. So here, let me just showcase some other things where this is a different kind of algorithm, shall we say, for that happening, which is cool. Or not algorithm, a different pattern. In this case, it's just like that, which this is the longest path I think it can take, potentially. There's a certain ratio where it's the longest path it can take to assemble, which we can see that this part, it's having a field day. It's very cool to see it actually happening. It's cool. Alright, and that means that in the future I'll be able to make vertices do the same thing. Okay, so this will be... Just do this. It'll be good. I guess this will be offset matrix. Yeah, I guess that explains it a little bit better. And this is new transform. There we go, that works out pretty well. I like how the zones are smaller. I am liking this geometry nodes update. It's looking like it will be better. Wait, does that mean that we can add inline sockets to groups? No, still can't do. Here we can see it's working as intended, with almost not 0 bugs, because again, the rotation's bugged. It's just bugged. It's good to see. And we have 30 people here. Hello. I know it's later in the day than the previous one, but it's nice to see everyone here. I could move the... Actually, wait a minute. I could break this out of the node group. I do like it just being easy to interact with. Actually, I could take the transform and then... Are there other... Transform direction. Ah, so I can do that. This is probably a terrible, terrible idea. Oh, wait. Oh no, that takes a direction and then outputs another direction. Okay. Let's see, let's look at the matrix nodes and see if there is a rotate matrix option. There's a rotate rotation node. I don't think there is a rotate matrix. So here we got transform, transpose matrix, multiply matrix, combine yeah, it doesn't look like we have that just yet. So we may need to just separate it for the time being. Transpose matrix, let's just see what that does. Fair enough. Okay. So the separate and combine is needed, but seems to be fine. Huge node group condensed into many little node groups. Yes, and there. Well, I kind of want to get rid of that frame. Let's do this. This will be vertex position, ROM, new, transform. There we go. Isn't that nice? More transforms, yeah, no, that's fine. I don't think we can optimize that any more than it already is. Could get rid of those 2 reroutes, which I think I will do. No, just a little bit cleanup here and there. Seems to be good. The scale I'm not manipulating, but now we can do that. Before, the scale was not really iterated on properly, but now it can be. I could just make this a matrix input, but actually no, yeah, I could just make that matrix input and we should be good to go. So just offloading more of the stuff that you see in here outside of the node group so that can be easily edited. So let's do that. Let's Control C, Control V. We don't need that group input. Here, it's just that, and then we can add in a new matrix group input. Get rid of everything else. There we go. Matrix. This is... Get rid of that, and this is just local. Here. Local transform. Here we go. Very nice. Very good, very nice. Does make this a little bit bigger, but it's okay. You can just, the user can easily see, okay, this is what's happening. You take the transform, you manipulate it, and then you put it back. Oh, yeah, there we go. This is now pretty much fully converted. And it's a lot simpler. Actually, I'll break this out of there. Because this part, it's pretty simple. You just take the rotation and you just flatten it. And that's like that. Seems good to me. Ever so slightly disorganized, but no. It's okay. So now, if we, well, the scale does not affect the scale. I could do that, couldn't I? Do that, and then I can just divide it by whatever I want. So in this case, if we divide by 1, that happens, and then if we do that, that happens. But I'll just disconnect it for now. Or, could do that. But there we go. Let's see. If it's not 0, do that, yeah. It's still not a small node group, especially if I were to take it out of all these sections, but I like the sections. I just wish that we could have a like sub-node group classification, like official one, that don't really appear here, if that makes sense. Or at least don't appear over here. Because having the sub-nodes like... Actually, wait. Oh, they're not appearing here. Okay. Oh, okay. No, wait, we already have that. Okay, never mind. But it would be useful to, have a subclassification so that this part doesn't grow super big. Oh, and that means I'll probably need to enable... Oh, they probably added versioning for that. But yeah, there's that. I'm just worried about that little precision error. Which means in some cases this won't be perfect. But it's as good as it can be. Alright. Good, good, good. Also, the frame offset is still there, even though I thought they fixed that. Where the snapping for the frame and the node inside the frame are just slightly different, which is extremely annoying. But yeah, that seems to be in a good place. And also, this rotation, you can now use the new rotate rotation node to do that. In this case, you take the rotation, now you can rotate like that, which looks really, really cool. In this case, I turn it into a vector, and then I smash the vector to 0, because that is the most convenient. Rather than undoing rotation, I just flatten it. There we go. Very, very nice. I do need to see how this will work in a proper, like, on a mesh with vertices. Well, the transform's happening all on the vertex domain instead of a face and then putting it onto vertices. Because with this, all the faces had to be split and then optionally rejoined afterwards. But, you know. It's good. It's so good seeing how optimized this is. Just in terms of the node layout. Well, compressed. Now let's go and just Control 8 there, and now this part isn't even needed. So now that huge setup that I had before is now compressed. I probably eliminated like probably 15 nodes in this case, just by using stuff that should have been used. Okay, that seems good to me. Now let's do another save. Yeah. It's amazing. This has gone through so many iterations. It said this is the 5th official iteration. I've had to go through so many iterations to figure out, oh, how do I get the parent face corner? This is the most optimized version of that, but in the past, probably half a year ago, I tried a method that would need a lot of repeat zones and all that, which it wasn't great. But now I think this is the most compressed version that this currently can be. Though I have a feeling. No, I think this is the most compressed it can be. Can I compress? No, I already did. I think this is as compressed as it can be. Because we get a rotation, location, and scale. All those are good. Then after that, everything seems to be fine. Except maybe the vertex local position. Maybe that could be optimized by just taking the regular position. Like, yeah, maybe wait, can I eliminate that completely? No, I would need an old transform and a new transform in that case. Transform old and then a transform new. Would that help it? Maybe I'll do a little test here. So that we could... yeah, that can be compressed. May make it a little harder for users to understand what's going on, but should be fine. Like, if I just take the position, so that the local vertex position doesn't even have to be gotten. We just take that. Then we take the old... No, but that would... Let's do a little timing comparison. Timings, that is 3 to 4 milliseconds. So it is just a little bit slower than the original. Slower in the face domain. It's fine, and then that happens after. Which that takes a little bit of time. Around a half a millisecond. I feel like it can be optimized. I would just need... Let's just take a look if I were to try. So let's have a 4x4 matrix, and this will just be old face transform. Which, if we connect... Or let's just do this. Old... Let's connect this to here. So that on the face domain takes under a millisecond. Okay, this may save us time. Actually, wait a second. We do have the face local transformation. Okay, this is completely unnecessary, but I do want to try it. So how do we transform the... Wait, actually, already know how to. We already have this, I just need to swap out face transformation for old face transformation. So right here, we can just copy this, put it over to here, swap out this with the old version, plug it into here, which means that that is now working. Which means that now we can just completely eliminate this part right here. And do we even need the new... I feel like there's a way of making it even better. But I feel like I'm kind of grasping at straw. Wait, what? Yeah, I forget what the phrase is. But here we've eliminated that, so that's even faster. Now this seems to be same speed. If you want to look at the timing, so this is around 0.6 milliseconds. Interesting. Very, very interesting. So we're doing 2 transform points, where we undo the old transform and we do the new one. But I feel like it's inefficient, because we still have the local transformation. Do the parents. How would I go and optimize that? This is getting so condensed, I'm loving it. But it feels like something is just missing. We have the position. The position is where the original face transformation would be. So we technically already have that data. So what if we just took transformation and then used a multiply matrix to undo the local transformation? Would that... So we take this and we do that. We can see that that's terrible. If we do this and then maybe swap that, okay, nothing happens. What if we invert one of them? It works! I knew it! Okay. It's weird how I don't really know the official math for all this, but I just have a gut feeling from playing around with these. And it actually worked. Oh, how about that? Oh, wait. Nope, that was... I forgot to... Well, at the very least, I did figure out a more condensed version of that. Okay, back to the drawing board. Okay, no, I wanted to get the local transformation, which does that. We do that, that doesn't done, and then we do that. Maybe invert is needed. Yes. out that with that, do that, and just try out this. Interesting. That, no. Okay. Let's go back. What? Vertex local position, or just, that's just vertex position. There's that. Face transformation, then face transformation old. Now I'm wondering if I even need the local transforms, or if I could do that live. I feel like I should have the local transforms. Like I could just get that live, but that would be extremely inefficient. Just constantly, yeah, no, that's inefficient. Constantly looking up the parent and doing that in a repeat zone, that's not a good idea. Because again, repeat zone, like I probably, let's see, there's a for each loop. But no, this has to be a repeat zone because it has to be done in sequential order. So it should be fine. This just seems to be the most efficient way of doing this. In terms of nodes. Just need the whole... Feels like that takes under a millisecond to do that. You know, I need the face local transformation because that's local to the parent. And this just exists. Store the transforms, and actually, yeah. Should go and swap this out for... Let's go and put this in here so that... Come on, work with me here. Be over. I wonder why it refused to cut. Bolt. No. Old transform. Go, and now I can eliminate that here because that can be done even for that, which means that's like that. Which means that at this point I could just get rid of the node group and I would be good. But I kind of want to keep that like that because, you know, efficiency's sake. Or just well, so that the user can see it, all that good stuff. So it does, oh, it does seem like this is the fast, well, no, it's still in the same range. Oh, and it's messed up. Why is it messed up? Uh-oh. Uh-oh, something wrong. Ooh. The old transform even working? It does do that. Okay, what did I screw up? That's in the face, yep, that's transform old. Did the name change? Well, it's a different wrong result. Why is that not? Okay, may need to reload the save. I screwed up something, and I actually do not know what I screwed up. Oh, that's why I screwed up. Circular and terrible. And there we go. Okay, now we're back. We're back. Let's go and collapse all these. Now, we just have a nice little setup right here, simplifying this tremendously. There we go. Let's see. All your nodes are so cool at your work. Well, why, thank you. Thank you for the support as well. This project I have not put up on my Gumroad page just because it was big, clunky, and not great. But now, with this new transform with its new transform capabilities, I think it's in a good place. We don't need the spreadsheet anymore, so let me just do that. I do feel weird about having this capture attribute node be here instead of in there, but it does make it more efficient. Is it called 4x4 matrix? Isn't it? Oh, yeah, in this case it's a 4x4 matrix because it has quaternions are more than... Actually, wait. Are they quaternions internally? I think they are. Here, let's actually check that a little bit. So if we just have a... Let's get an object info node, because, well, wait, object info. Let's... Oops, I did not mean to do that. Oh my god. Okay, combine, location, rotation, scale. There we go. Let's use, just a random thing. Take a look. Oh, it is not being evaluated. Let me use a store named attribute node. Let's also assign that as a quick favorites. Let's go and do that. Plug that into there just so that we can see. Okay, come on, cooperate with me. Okay, so here's the matrix with the rotation, location, and scale being that. So I forget which one is the rotation. We can see that the scale... Okay. I'm assuming that the 3 diagonal ones in the bottom right corner are the scale, being 1, 1, 1. And then... Dang, I really forget which ones are which. Then... actually, wait, I don't know. I think body 004 is at 000. So I'm assuming that the 3... No, that doesn't... Wait, why would the quaternion be first in that case? I don't know, I'll need to look up which numbers correspond to which parts. Yeah, I actually don't know. Well, I'll look that up another time. Upper left is 3x3 for rotation. Oh, okay. Upper left. So it is a 3x3 matrix. It's not quaternions. Interesting. I'm assuming that's the most efficient way, or else they would have just used quaternions by default. Actually, yeah, I need to look that up. Why do they use, I guess programmers in general, why do they use 9 values to represent a rotation when a quaternion is 4? I'm assuming 1 is the most efficient way. I'll need to look that up. Okay, let's go and delete that, connect that over to there, delete that. Okay, this is now the most efficient way of doing this kind of face stacking. Which, oh, this was originally inspired by Intagma, who did it in Houdini. But the Houdini method took... It was difficult to understand because it was mostly Vex code. And I wanted to make it in geometry nodes, which is, for me, easier to understand. And yeah. It's a stream from earlier anywhere on your channel. No, that is not available anymore just because it wasn't really informative. I was looking at the transform nodes and I couldn't figure them out, the other parts, and then the last part was looking at EV next. That was something. That was something. Let's see, the 3x3 rotation matrix can directly be incorporated into the 4x4 transform matrix, such that translate, rotate, and scale can be executed all at once. Okay. So even though it is a bit more expensive due to it being 3 floats, or 9 floats, it's better integrated into the kind of transform system. all seems to be good. Technically, this has a start face, but since you can't assign face attributes directly, at least last time I checked, I don't think you can assign them directly. At least unless you have an actual tool for that. Well, if I may ask, with the multiply matrices part, I originally thought when I first looked into it that multiplying it would just multiply every single row and column by the corresponding one. I'm assuming that's not what happens under the hood because swapping these leads to very different results. So I'm assuming that there's a proper algorithm doing all that. Order of operations and such. See, that's all good. Capture attribute. Could collapse that, but I want it to be shown that that's on the edge domain. And that has to be captured beforehand because when it gets swapped to the dual mesh node, I know that has to be done. Start face does that. Let's see. You have time before you go. Can you do a quick overview of face rolling system showcasing? Yes, I will do that. Eventually, when this actually comes out, I assume that I'll be able to fix some things because there's currently a bug, the rotation socket, where if it's 0, it for some reason will throw out 90 degrees, which is extremely annoying. I'm assuming that it will be fixed, which means that if I add in a workaround to undo that rotation, it will be a fix would break that again, but at the moment I'm just incorporating a little float, just the tiniest float value I can so that it will never hit absolute 0. Several interesting visualizations for that. Yeah, I'll need to look into that. Because quite often when I often learn the parts of geometry nodes as they're introduced. You know, I was going to say use it or lose it, but if you never have it, can you lose it? The matrices, I've heard a lot about them, and they are in Blender source code quite often, so learning about them is very, very necessary. I also need to look into, I need to update the custom Blender build I'm working on. Or just the custom nodes I'm working on, because I want to see if I can access the camera transform, then directly output them into my camera. But that's for the future. Okay, let's add those. Ignore that for the time being. So I'll just write ignore on that. Okay. I guess now I can do an overview of the setup. I still feel like the local transforms I could and should fix up. Let's see. Actually, I'll rename this so that it's a little more in your face. So face, old, transform. Yeah, that's better. Less confusing because I already tripped myself up once trying to... Okay, let's turn off the timings so that we can see that all well. Like this part, I may switch up a little bit to possibly use the local transforms in order to figure out how to do it properly. No, I would need the face transform. No, this is the best option so far. Let's not make this any worse than it has to be. Okay. Let's see. Hello, I have a question. Is it possible to render an animation scene made in Blender in Unreal Engine? Reduce render time. Directly, no. You would have to export it as like a USD, and your scene would have to be compatible with both engines. You would have to use textures. It wouldn't support custom shader setups. But the meshes you can export as like an alembic, and that may work. Some materials are supported in alembics, you just need to make sure it's correct. So there are pipelines that export from Blender into Unreal, animations and such as that. But it's not one-to-one. No program has a one-to-one conversion, and if it does, that is a miracle. Quite often, converting from one space to another feels like it's held together with duct tape, but it technically, no, but there are ways of converting a Blender scene into an Unreal Engine scene. It's just a matter of how detailed do you want it to be. Alembics or USDZ. I think Alembics are the best. I'm not sure if USDZ's the USD format. I'm not sure if that even works in Unreal, but Alembics do. I would recommend looking that up, because even though I've had to do that a couple times, I do not know the full extent of that. Okay. Let's see. For Brayden, I apologize if I'm pronouncing your name wrong. Let's go and do an overview for this node setup. Let me just check something really quickly. Okay, we're making good time on all this. Even though it's 1 hour, let's go and review this. What do the matrix nodes look like? We can take a look at that after the review. Okay, well, this is just edge cost. Yeah, let's just do that. Okay, so let's review this setup. So this is a mesh rolling or mesh folding algorithm where you assign a vertex group. In this case, this vertex group is on the bottom of the mesh. Or should be. Actually, is it? Yeah, the start face is this vertex group, which is at the bottom of the mesh, but I don't know why. Oh no, it is there. It's just a little bit hard to see. So this takes a vertex group, and internally here, it goes and takes that start face, which I don't know why I captured it like that if it's not really used. Maybe I can make that more efficient, but anyway. This is a bit... Can I just optimize this? Okay. I'm going to go and optimize this to the fastest method, most explainable method. So if you bear with me for a quick second, let's go and do this. I'm just going to eliminate all the unnecessary nodes. This will be I'll just have this be a value. That needs a value of 1. Something like that. Let me put that over there. Let's go in this. There we go. Okay. It'll be ever so slightly inaccurate, but this is just the easy to understand version and the least experimental. Okay. Let me just go and make sure everything unnecessary is eliminated. So with this part, it will always choose the shortest path, but there is the more complicated way to make it the longer path. But for this explanation, let's just use the shortest path because it is simpler. Control Z is not doing what I wanted to do, and I hope I didn't break anything. Oh, it was an edit mode. Okay, so we should be in a good place. Okay, so here's the... Let's enter this and make it all good. This is the mesh folding setup. So here we have a start vertice, which gets converted into a start face, but there's one vertice with the vertex group assigned. We go and feed this into the parent face node group. In this case, we go and take the start face, and then... Okay, no, let's restart that one more time. I'm going to eliminate... Actually, no, we can... It's just a little unnecessary. Yeah, no, that's unnecessary. Okay, let's shorten it even more. I want the most compact version to be explained. Okay, let's take 3, I guess. Okay. So here's the mesh folding algorithm. We can see at the bottom here, there's one vertice assigned to this vertex group. We go and put that into a shortest edge paths node after the mesh has been converted to a dual mesh. So this converts the vertice assignment to... Actually, yeah, it converts the face assignment to a vertice Nope, we need to... I'm reminding myself of this, but I want to get one good take, because I may convert this into a YouTube video. But, okay, let's do this again. So, this is the mesh folding algorithm. We can see at the bottom here, one vertice is assigned, which is the start point for the shortest edge paths node. But there's something special about this, where there is a dual mesh conversion. So this turns the faces into vertices and vertices into faces, so on. That means that the shortest edge paths node can operate correctly, because in this case we want the face parents and just all that information rather than the vertice parts. So that happens, and then we take the next vertex index and the total cost, and then we transfer those back to the main mesh by sampling the points and then putting them onto the face. So that happens for both of these. So here we want the face parent ID and then the loop ID, which is just a value that goes up from 1 from the start, and then outwards it's, oh, here's face 0, 1, 2, 3 going out from the center, so that when the folding happens, it happens in the correct order. Beyond that, we then find the parent face corner. This is mostly so that it'll rotate in the correct place. So in this case, we find the corner that's not on the self face, which this is just an algorithm to do that. It's a bit complicated, so I don't fully remember it. And then we check if it's on the parent face. If so, that does something which makes it work correctly. And then the corner index, all of this goes and finds the corner parent, which is the face corner that is on the parent face. Then we use this little thing to get the second face corner parent, if that makes any sense. So basically, to explain that part, let's say this face right here, let's just go and make it a little visible. Let's say this face right over here is parented to this face. This means that the parent edge, or parent face corners right here, are here and here. Can you see the, there we go. This face is parented to both here and here. It just gets those two positions. So later on, that goes into the store transform section, where we need both of those face corners. So we take the face corner parents, we mix the two, and we can get the center of that edge, kind of. We use face corners because after the split happens, the edges would be all messed up, but face corners stay the same. So we get the center location, which if we manipulate this a little bit, we should see a little difference. Maybe not, because it's on there. But then we get the rotation, which if you subtract one face corner from the other, you can get the x axis for the rotation, and then the normal will be the z. Works out pretty well. A little bug fix right here, just because there's currently an issue with Blender's rotation socket, where if it's 0, for some reason it'll default to 90 degrees, which is not good. I believe there are bug reports, so this will probably be fixed by Blender 4.2, I hope. But if it is fixed, just eliminate this node entirely. It'll be more accurate. So there we store the face transformation right here, just a location, rotation, and scale put into a 4x4 matrix. This is only available in Blender 4.2 at the moment. And then we also store the current transformation. This is so that after this transform is manipulated, we'll still have the original transforms for later. So with that, we then split the faces so that they can be manipulated just fine. We split the faces so that the vertices are duplicated and they can be then moved afterwards without turning it into a mess like I will demonstrate here. There we go, it just works. So now with the local transforms, this is fairly simple. We get the face transforms, we invert the transform from the parent, which is evaluated again on the face domain. Then we multiply the matrices, which basically gives you the local face transformation. That's the goal. And then with that, here's the semi-complicated part. We then have a gradient, which just controls a parameter. In this case, it flattens out the rotation. But let's focus on the important part, the stacking face transforms. So here we have the face local transform. We mixed it up a little bit. In this case, we're just flattening the X rotation, be 0. So in this case, it starts out and Actually, no, in this case it's not flattening. We set it to be a 90-degree thing right here, as we can see there. In other cases, we can see that they get flattened out. It's good. But in this case, the local transform gets manipulated and then stacked, which in this case, we have a setup where we have a repeat zone looping over the loop ID. So at the first repeat, it happens over all the faces where the loop ID is 0. In the next loop, it goes over 1, 2, 3, and so on. And every iteration, this goes up by 1 so that it will work accordingly. But with the actual transform that happens, we take the local transform, which we manipulated, and then we multiply it, or offset the parent matrix, like that, and then we go and reapply a new transformation, just like that. Fairly simple. This section right here just finds the maximum loop IDs, adds 1, then you can set a max iteration count just so that it doesn't lag your computer if you have a massive object that you accidentally put this on. This just says, hey, however many loop IDs that are needed, just do them. You're good. Also set a max iteration, just in case. Then here is the last section. So all of those transforms were happening on the face domain. So how do we convert that into a point transformation? Well, in this case, we just take the position, then we take the difference between the current face transformation and the old face transformation. We take that, multiply them together, and then transform the points, and then set the new position. So all of this is very efficient because all the heavy matrix transformations happen on the face domains, which means that there's only about one face for every 4 vertices. So this happens about 4 times less than the position stuff, and that should be good. So with all of that, basically a complicated way of making the faces roll around relative to their parents. There may be more efficient ways of doing this, but this is the most efficient way that I found so far, using the new matrix nodes in the past hour. So yeah, that is the overview of the effect. I hope it was good enough. If you're wondering what's happening with this right here, this basically controls the rotation part. This just makes it so that nothing can happen on the first loop, because if that does happen, some things can go a bit weird, but actually, yeah, we can see here, the rotations happen there, which you kind of don't want. So I just have it so that, hey, if you're the first loop, you are static, you are stable, you will not move. Then this gradient is just, you know, a range based off the loop ID, which works out well. Okay, now that we have that, let me go and reopen up the file. Hopefully the save was good. So I didn't mess anything up. Okay, we're good. I just need to fix the naming right here, so I'm just going to make this bold to make it just like the thing I just said, because that is better. Go over to here, transforms, old transform, good, that all works. Go and join the areas, do that, save. So the reason that this was a little bit more complicated was because if you don't want the edge cost to be just 1 every single time, if you want it so that it takes a different pattern, you need a way of getting that loop ID correctly. So this is the method of doing it. You just have an edge cost, which manipulates the next vertex index, and then you do that. And then that's how you can get the face parent. But if you take the next vertex index and then put it into the edge paths 2 selection, you can have that be another edge cost. But if you set the fastest path to be 1 and the most expensive to be like 10,000, you can get that edge cost correctly, and then you feed that into there. It's a bit more convoluted, but it works. It works the way it's supposed to. With the start face, I feel like I can eliminate this and there be no real repercussions. I don't know why I should keep that, so I will eliminate it. It seems okay. Like maybe I should put a capture attribute node on there. Yeah, let's do that. Let's use a capture attribute just on the off chance that things could go So let's make this a boolean on the domain, just in case. There's one more named attribute that we do not need to deal with. I think that's good. So all that's basically, it's because, actually, I need to look and see if I can mod that into source edge path node and then put that as a pull request. There are bigger fish to fry when it comes to that. You just have to do a workaround in order to have a user customizable edge cost and then get the loop ID from that. So lots of steps for something that should just be an output of that node. But that's basically the complicated part. This part I just captured beforehand because I could put that internally. I could do other things for it to be more. Here we can have the shortest edge path cost, which is the. Uh-oh, what did I screw up? Screwed something up again. And please tell me save the broken version. Oh shoot. Oh no, that's why I did. Okay, that's why I stored it as a named attribute so that I can tell. Oh, okay. Okay, well, let's rewind. I had it as a named attribute so that it could be teleported over easily without a ton of spaghetti. But it looks like the spaghetti is very necessary. Let's just have this as a boolean. I also wonder why an 8-bit integer is there, but I'm not complaining. Interesting. It's more efficient, I'm assuming. I also find it funny that just the stored named attribute. I guess the capture attribute node by extent. Actually, no. Okay then. This node really is the most valuable node in geometry nodes. It gets all the love. Which is expected. It is the best node we have. Makes all the node trees more efficient at the cost of just a little bit more stored memory. It's not that bad. It's fine. Let's go and put this over to here, and then I could go and put that name back. Same name. It should work. Let's see. Yeah, let's just reference there and there. Actually, it would be cool if when I clicked on this, all the other ones with the same name would light up. Kind of like, kind of like coding. But that would be a mod. So there we go. Oh, I like that one. I think this is the... No, there's no way this is the longest path. That's close. See the one in the background freaking out. But yeah, that's the face rolling algorithm. Mesh folding, face rolling, either one, it works. But this is so much better than even the Matrix version that I made originally. Just a few new nodes, and then it is so much. But maybe I'm still not sure if it's faster or slower. I think it might be just a little bit slower. But in this case, I think that's acceptable. Do you have experience in using Vex in Houdini? A little bit. It's been a while since I've used Houdini, just because in my workflow... Hit the microphone again. In my workflow, in my work, Blender is the #1 tool that I need to use. Now, I've used most of the other 3 programs like Substance, Houdini, Unreal. Unreal is the second most common program that I use, just because my work requires it. But I have used Houdini. I do like it. It's good, but it is just more inconvenient than geometry nodes in my workflows, because with stuff in Blender, it's much faster to just edit it in Blender. If it's like, oh, I need, to delete these faces by this vertex count and all that stuff, you could pop that into Houdini and do that, or you could just do it in Blender. geometry nodes, it's funny. Geometry nodes is good because it's integrated into Blender, but it's also not that well integrated into Blender because you can't access the scene data currently, at least barely any of it, because there's some dependency graph issues. But even though geometry nodes is less powerful in those terms than modifiers, I think, actually, no, modifiers are just fine. Even though geometry nodes can't directly access scene data, it is still incredibly useful because it is just in Blender and is just like a modifier. Making assets is very good until you want to make it so that, oh, I want this geometry nodes asset to reference its parent object. That I've had to build my own node for in C++, and apparently it just won't work because of the dependence. It won't work as well as it should because of the dependency graph, which really sucks. If it changes, if it's just one parent and it does not change, which actually, come to think of it, it won't change. Actually, wait, no. That one should work perfectly. No, unless the object gets swapped and all that fun stuff. Anyway, who knows? But, yeah. Geometry Nodes is very good in Blender, so if you use a Blender workflow, Geometry Nodes is much better than Houdini in most ways, just because of its integration. But Houdini is much more powerful if you have any other pipelines. Like if you're in, say, a film production, and there's people working in 3ds Max, Maya, so many other programs, you're probably going to use Houdini because those are in the pipeline already. Because people will be like, okay, I exported this alembic of this character doing this thing. Let's have the rock collisions and all, you know, the bridge explosion or something like that. The destruction effects and all that. Well, you would do that in Houdini and just import the alembic of the character animation, do the explosion, export the explosion alembic, and then you're good. And the VDBs, of course. And then whatever program they use for the final renderer, whether that be Arnold, V-Ray, all those, and whatever program they use, I would assume they'll probably use like Maya and probably, I forget what the default renderer in Maya is, but it needs to be good enough to work in a pipeline, which my pipeline is basically all Blender, and with some Unreal Engine. And since it's mostly Blender, things that are integrated into Blender are the most convenient, even if it's lacking in power or something like that. It's just more convenient. And also, I do really like just the store named attribute, and these two nodes are why I like geometry nodes. They're just so incredibly convenient, and the rest of the node setup being like a shader editor, that's really good. But these nodes, just how convenient it is to just go and store the data on the right domain that you want, and in the right data type that you want, it's so convenient. While in Houdini, it takes a few more steps. Shortest path. I hope that's... I hope that wasn't too rambly, but I think I explained it good enough. It all depends on what pipeline you are using, which in my case, it's the Blender pipeline. It would be good if I did properly learn Houdini, but for that I would have to use Houdini in my workflow all the time, which I don't need to. Like in my workflows, quite often, if I'm doing like model cleanup or something like that, geometry nodes has come in clutch many times. Just being like, oh, what's the state of the mesh? Okay, let's go and manipulate it, delete what I need to, or do something like that. Geometry nodes has been very useful in my work. But, you know, Houdini would probably be more useful, but since I would have to export the file as an FBX or something like that, it would be more annoying to do so. I hope that explains it. Let's see. Thanks for the answer. Oh, that was the Unreal question. Yeah, Unreal Engine can be used for product animations, but that would probably be a more Unreal-centered ecosystem. And I think they have a mode. They've introduced a mode for that. I forgot what they called it, but it's like... Sorry, just checking the time. You would like have your asset, export it as an FBX or GLB. I would recommend GLBs because they're just a little bit more convenient in most cases. And then you would import that into Unreal Engine, do your animation inside of Unreal Engine, and then set up your lighting and all that, and then you're good. You can, again, export the animations into Unreal Engine in most cases, but you would have to rig it, and then... I forget what parts are supported and which ones aren't, but there are different ecosystems. The Blender ecosystem is rather unique, fairly unique. So it meshing with Unreal Engine is very difficult. Like again, like geometry nodes, actually no, someone has made a kind of wrapper for geometry nodes inside of Unreal, where if you make something in GeoNodes, it can be converted, which is very interesting. I think that would need a lot of upkeep to make sure that it stays updated with all the new things that they are adding, like the new sockets, I would assume. Yeah. And there are plugins for like Unreal Engine and Unreal compatibility to an extent. But again, it's very finicky. Alright, I think that's everything for today. Using the new matrix sockets in a practical application, seeing how much it optimizes the node setup. I'm very, very happy with it. But other than that, I think we're good. Just to wrap up the stream, there are some new nodes that are also cool coming to tools, one of them being the viewport transform, which I do need to look into more, because I need to see how this works properly, because this data, the projection, I'm assuming it's like the window scale, but I do need to look into that. Why there are two matrix transformations. I'm assuming the view is just the location of the location and rotation of the camera view in the viewport, and then the view is the X and Y scale. Then there's an is orthographic thing. I need to look into that. I'll probably need to dive into the source code to see what's going on and see the comments. Actually, wait. Yeah, but that doesn't explain all too much. It kind of explains it, but maybe I'll play around with it for a bit more. And I also wish we had this in the regular modifier, in the geometry nodes modifier view. Either for the camera or something else. Because we need that a lot. I've made an active camera node, but it really needs, particularly the aspect ratio for camera calling and all that stuff. I've tried to make it work, but it's just not quite there. Not quite. But yeah, cool stuff. Oh, and also the mouse position. I need to figure out how this works, because there's a lot of stuff where these are good building blocks, but they're not convenient. Where, to the point where it's like, okay, if I do this, my camera will be in this space, so on. I understand why they did it, but like this will need a fair amount of research before I can be like, okay, if I click here, then I'll send a raycast. Like, just basic clicking functionality, it'll be kind of difficult for me to figure out, but I'm sure it'll be fine. And they're also planning for modal operators eventually, but I highly doubt that will be this year. I highly doubt it. It would be interesting how they manipulated simulation nodes to do that. Because I assume it's a very similar, or it wouldn't be a a similar thing. Like with modal operators, I'm wondering if they're meaning like extrude, where you click and then you can decide how high it is, or it's like the cloth brush, where you click and then an entire operation happens. Could be either, I don't know. Where an entire operation iterates like every time an update happens. I don't know, but it could be really, really cool. Regarding the rotation issue, do you know if it might be caused by an older rotation gimbal lock? I highly doubt it, because I think the rotation sockets are either 3x3 matrices under the hood or quaternions. I'm assuming because in the regular transform node, they're 3x3 matrices, then they can be converted into quaternions or boilers. So I highly doubt it's either one of those, because it glitches out both times. Actually, does it? That's something I need to check. Does it glitch out when there is just a rotation node? So if I just put this into here and do that, if I take out that little. Oh, how about that? I highly doubt that it's. Actually, wait. No, it's probably still messed up. But since that's happening, let's try rotate. Rotation. Do that. Plug it into there. Get it. Yeah, no, it's not that. I'm assuming it's a quater. I assume it gets converted into a quater in an order necessary. But yeah, that's that. We need to re-enable the little air mount so that doesn't go out. It's very unfortunate that. Okay, I thought there was another error. It's unfortunate that these bugs just keep popping up whenever there's a little error here and there. But yeah, it's fun. I don't think there's a way to avoid it either, besides storing an attribute and saying, hey, if this is 0, 0, 0, then have a value, store another boolean, and then do that. That would be the workaround. That would be extremely dumb. But it is what it is. Okay, we're at 1 hour and 42 minutes. That's a lot longer than I wanted to stream for. But with this, seeing how it's a new major upgrade to how we will be working with basically parent relations and geometry nodes, it was worthwhile. Have you tried simulating a plant growing? Kind of, but I wouldn't recommend using simulation nodes for that. Which brings me to another topic, which I think is very good. With FX, simulations may be more accurate if you get the physics working. But is it worth it to sacrifice a lot of the art direction and control for something that's a little more physically accurate? Because if you wanted a plant growing, chances are you don't want all the mass working entirely, because that's very unpredictable. You probably want something where you have a predetermined mesh just object, where you have a flower with alpha cards for like some of the leaves, stable mesh for the stem and such. You want that, and then maybe you would have like, I don't know, a skeleton that you shrink and grow, or just shrink and grow the mesh by itself. Just work. Actually, that reminds me, I have another transform setup that I need to optimize with tech. Actually, I think I may, let's just make this a long stream, because it'll be quite a while before I stream again. Keep clicking on the wrong screens. Okay. Let's see if I can remember which one. It was the save that. The ground crack instance default. So some of you will remember this project. from a while back, because this uses some transform math. Going back over to here. Oh, sorry. At the very beginning of the section of the mesh folding, what value do you have in the greater than node? 0.5. It's probably not too important. It's either 0 or 0.5, just so that when it gets converted to a boolean, it's okay. So 0.5 or 0, you just need a boolean as the output. It's not too important. But you just need to make sure that a face ends up being selected. With vertex groups, it's a little bit weird, because you assign vertices, and then that can be interpolated into a face, which in this case it was, which is kind of why the greater than is there, but it's just a little bit funky. So, it was either 0.5 or something near 0. You just need a face selected for it to function properly. Okay, so the deform stuff by stuff. We can see here that it looks like quite a bit of this can be optimized. And I'm not looking forward to this. Okay, maybe I'll save this for another time. But yeah, this can definitely be fixed up. Then you'll... Whoa! Sample nearest surface got an upgrade. They finally added that. Wait. Sample nearest. Sample nearest index? Oh, wait, no, they didn't. Oh, dang it. I do like that they added that, and I need to look into it, but... I need to look into that a bit more. There's an is valid input. That is good. Proximity, geometry, proximity. Yes, they... Oh, that's very interesting. I really need to look into that. The is valid thing is extremely useful, because before, if there was no valid input geometry, this would just be like the distance to an object would be a lot, because it was, well, very... If the distance was 0, then sometimes some setups I had would act like, oh, there's stuff everywhere and all that fun stuff. So it's very good that there's an is valid input. I need to test out the group ID and then sample group ID. Kind of feels like they're trying to get the like for each functionality without an actual for each loop. Nearest index of nearest. Oh, they did not add that. They did add a has neighbor thing into there, but the sample group ID is not. But this is very, actually, I need to, now what does that do? I'll need to look into that, but it's very interesting to see. New functionality, good. I'll take one swing at understanding this, and then I will just straight up give up. And then call it a day. So, let's see. Store all of that. That's the offset. Disk position. Fine. I need to remember how the original does the thing. Actually, wait a minute. I could convert just a little bit of this so that I could only have to transfer one thing. Yeah, that could work. Okay, let's try to fix this up a little. So let's change this into a 4x4 matrix. Then combine all these. So combine. But there's a problem where this needs the original position. Instance transform has been exposed. Oh, this is really good. This fixes a lot of problems I had with instances before. Oh, thank goodness. Okay, store named attribute coming in clutch as the most useful node ever made. There we go. So let's just go and look at instant transform right here, and we can see it transforms it all to 0 because there is no valid input. Rotations seem to be the same as well. Oh, that's so good. Stored named attribute is the best node we have because it's basically a catch-all. If the devs haven't gotten to implementing like a dedicated instance transform node, we just have this and it works beautifully. Okay, let's use a combine combine transform. Wonder there. So here we can set that to be that. Interesting how the, oh wait, that's because of the, just go and look at this. There we go, that sets all that to 0. Now we can finally actually set instance position, rotation, and scale. That is so good. That is, I'm so happy. Also, we can use a little transpose matrix in order to do some funky stuff. This feels very, very wrong. But you can go and do some weird projection stuff. That is so good. That's so good. Because usually when you do that, it does that. You know, you scale it and then you can rotate it. Scale happens first, rotation happens second. Then translation happens last. This, it seems to kind of shuffle the order. And position does nothing. This seems to make it so that scale happens second, rotation happens first. That is very trippy to see. It's so cool. That, and so if this is muted or not, oh, it does flip around some of the orders of that as well. It's so good. I'm so happy about that. Okay, so now I don't even need this. Don't even need it. It's so good. I'm so happy about it. Sorry if I keep saying that. Then the offset, rotation. But why do I have the original position there? There, but it is. We do those two sample the live position, and that one samples the original. Why? Actually, not. Well, this probably needs to be remade anyway. So, okay, let's go and do a little combine, transform. Now that can be sampled. Location. Scale, yada yada. Or no, it's for the instances. The original. Yeah. Oh, the pivot point. Oh, that. Because that's the instance. Okay. So technically, I think. Let's go and mute this for the time being. If I go and connect to the original. All these, nothing should. Then. Okay, good. Okay. The only thing that absolutely needs that is. Oh, that can be connected and nothing. Too much value will be lost. Offset. That, and then. Oh. Interesting. Yeah, this looks like it'll need a remake, which will take me a good amount of time. Do that, and then do that. Then I would need to... And it's having that rotation error again, so I'll need to add in just a little bit of error. Then I think I need to multiply matrices with the instance's own past transform. This is so good. Named attribute node is the best node. So here it seems, yeah, okay. It's already kind of working, but something's very messed up with it. I know it. Oh no, it's working because all that other stuff is connected. Just go and do this. No, it's still kind of working. It's not entirely. Yeah. Need to figure out how to make it all work in one go. There, let's just go and do all that. It'll need to be remade because I'm definitely not doing just hope it's efficient. This right here takes 3 milliseconds for storing just that. For doing that. That's a little expensive. I'm gonna go and open up the main file once again, just to see how much that was previously. Take a look inside the node. After the node, I have some other physics stuff happening, but it's kind of great. Okay, no, it is faster. Good, 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 good. Okay, let's do this one more time, and then I'll end the stream, because we have just a few minutes. So, let's go and keep you, but I can delete, no. Chain. I want this to be a combine. Transform location, which, do I even need the offset, or do I want to? I don't know. This makes it so that all that has to be evaluated just once, instead of the weird 4. Delete you, and then just have a stored for that, make it, build to write, yep. Go, and then a multiply matrix. So this is like the parent location, and then that's the offset. So here we can see something's happening. That glitch is happening, which is very, very annoying. I hope they fix that by the time all this gets released, because that is really, 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 really bad. Really, really, really bad. But for the moment, as a little bug fix, just do a vector math add and add in that much. If you can't see the 0, apparently it just won't. But we can still see that some popping is happening, so it just can't work whatsoever. Or I could just make it so that if it's equal to 0 at any time, it will just switch to... Yeah, no, this is a better way of adding in that bug fix. At any point, it's at 0, and it'll swap it to be the other part. So this should mean that it will never glitch out. Some parts may be inaccurate, but it's a price that we have to pay due to bugs. I should probably fix that in the other thing. Annoying setback, but anyway. Okay, let's go delete these. And we still have 25 people here. Hello. Yeah, that should be fine. So ideally, I would have it so that a lot of this is just better, so that I don't need to store all of it, but we'll figure that out. Sample group ID. So interesting. I wonder, that has to allow us to do a lot more stuff. So there's still something wrong. Where that offset... And that doesn't work, but it does look very cool. Because I think with the multiply matrix thing, it's still keeping the instance location when here we're replacing it. So in theory, I should be able to just separate the transform for both of them, and then just combine the transform, so that we just take out the location data, its old location transform. Oh, it's close. Wait, is the offset in there again? Oh wait, why did... Oh no, yeah, that makes sense. And then that's the rest position. I could have that plus the offset. It's so close to working. I can feel it. Why are there two of them? Huh. Well, it's close to working. I will figure it out. Like, I should probably go and then remake it from scratch, because trying to convert an old system is not a good idea. And we are past 2 hours. I wanted to keep this under 2 hours. So bear with me while I go back to the old file just so that we can wrap this up. Okay, thank you all for watching. I'm going to go and fix that one last part with this part. Nope, not that part. This part for the bug fix, so that we can just use an equal that, and then we'll just switch there. Switch that to there. So here is the better bug fix for the current bug with the quaternion rotation socket. We just need that so that whenever it's 0, no it's not. So that's good. So now this should be pretty much airtight with minimal errors. Minimal errors. I could probably make it even smaller, but actually, can I make it even smaller without it breaking? Just do that. Nope, it still breaks. Okay. So that's that. Thank you all for watching. I hope you all have enjoyed this little optimization using the new matrix nodes in Blender 4.2. Keep an eye out for some new nodes coming in the future, because those will be cool. Yeah, thank you all for watching. I'll see you next time. Have a good one.